Welcome to another Panther Math Corner. This is Dr. Irvin Howard, math teacher for Pasco County High School. And again, I want to welcome you to another Math Corner, Panther Math Corner. Today's series of lessons involve quadratics. So we're going to show you how to solve quadratic equations. I'm going to show you how to solve quadratic equations using square roots. There are three scenarios to where you would solve quadratic equations using square roots. The first one begins when x squared, in the format of x squared equals to d. D is designated as some value that equates from the x squared. When you have this scenario, d is greater than 0, there exists two real solutions. Two real solutions. All right, two real solutions, and I'll give you maybe two examples of solving in the format x squared equals to d when you're using the square roots to find the real solutions. All right, so we're going to test those values right now. Example, x squared equals to 25. All right, we see here that d is greater than 0, so 25 is greater than 0. That means that the real solutions will be two real solutions. And let me demonstrate. Now that we have this in this form, we use the square roots. And that means that we simply square root both sides, or find the square root on both sides. All right? So like equations, what you do on one side, you do on the other side. So we found an x squared equals to 25. We square root both sides so that they would cancel. And later we'll talk about why they cancel. All right, but in this case, solving square root, you just solve it square root on both sides. And anytime when you have an x squared, the square root will cancel and you will have regular x. But the square root of 25 gives us a plus and minus 5. So if we look at the square root of 25, the answer would be 5. So there exists a positive 5 and a negative 5. All right. This is what it means when you square root the equation x squared equals 25. Square root on both sides, and you'll be able to find two real solution values. In this case, 25 represents a perfect square. So if we look at it as square root of 5 squared, all right, when you square root that, the answer would be 5, but it will be a plus and minus 5. Noting that there exists a negative value and a positive value. All right, let's try another one. This time, let's try something a little different. Let's do this. Let me erase this. And let's do something a little more trickier. Solve 3x squared minus 27 equals to 0. All right. Likewise, we have to make it look like x squared equals to d. All right. So before, let me put it here. So we have to make this. We have to make this equation. We have to make 3x squared minus 27 look like x squared equals to d in that format, so that we can take the square root on both sides. So it has to be in that form. And then we have to test it to see if it's greater than 0. The d value is greater than 0. So how do I get 3x squared minus 27 equal to 0 to look like this. All right, easy. All you have to do when you solve an equation, we have to get the negative 27 on the other side. And how do we do that? Let me write this over again. All right, so we're going to add 27 on both sides using the properties of equality. All right, negative 27 and positive 27 cancels. We have 3x squared equals to a positive 27. All right, now the final step, we have to get rid of the 3 in front of x squared so that it looks like this. So we divide 3 on both sides. So what we do on one side, we do on the other. So the 3 here cancels because of the reciprocal. X squared equals to 9. Let me show you. All right. So now we got this to look like that now. So we're cooking with oil or cooking with gas. Okay, so we're going to burn. So now x squared equals to 9. And 9 is greater than 0. All right, so there exists 2 real solutions. So all we have to do is take the square root on both sides. X squared equals to square root of 9. Square root of x squared is x equals to, let me put it up here. X equals to, what is square root of 9? It is 3, but when finding quadratic equation, there exists a positive and negative value according to the rule. So there exists 2 solutions. X equals to a negative 3 and x equals to a positive 3. All right. Okay, that's the first scenario when d is greater than 0. Now, the second scenario when d equals to 0, there exists one solution. I'll change this a bit. Okay, I'll change this a bit right here. All right, so there exists d equals to 0. All right, there exists only one, fix this up, one real solution. Okay, one real solution. So in this case, whenever the value d equals to 0, there's only one solution. So let's test it. All right, let's test when that value equals to 0. All right, so let's do let's solve this one. Solve x squared minus 10 equals to a negative 10. All right. All right, so this is a little different because you have x squared minus 10 equals to negative 10. Like always, we want to make it look like this. X squared equals to d. All right, we want to make this whole equation, quadratic equation, look like that. All right, so what we do, x squared minus 10 equals to negative 10. We add 10 on both sides. All right, and look, wonderful thing's going to happen. All of this cancels. X squared equals to 0. And look, the d value will equal to 0. Because anytime you find this is 0, you know that something's going to happen wonderfully. It's going to be 0 anyway. So, but we looked at this value, x squared equals to d, all right, but d equals to 0, all right? So let's make sure that meets that condition. So we find the square root of x squared equals the square root of 0. X equals to square root of 0 is 0. So it makes d equal to 0 true. So there's only one real solution, which happens to be x equals to 0. Okay? All right, that's the second scenario. Your third scenario is when there's no real solution. And this is when D is less than 0. I'll change this up. D is less than 0. And let's erase this. And let's do a test to see if there's any real, there is no real solution. All right, let's test this scenario with another example. Solve negative x squared plus 11 equals to 16. All right, like always, we want it to look like this whole equation to look like this. All right, so let's begin breaking it down. All right, so we need to get negative 5x squared by itself plus 11. I'm just writing it over, equals to 16. Subtract 11 on both sides. Negative 5x squared equals to a positive 5. All right. Now, to get rid of the negative 5 in front of x squared, we simply divide on both sides. All right, so we have your x 5, negative 5 cancels. We have x squared equals to a 5 divided by negative 5 is negative 1. And look at this. Right, we have x squared equals to negative 1. So if we try to find the square root on both sides, we'll have x, but this is what we have. We can't solve it. It's not a real number because there's no such thing in the real number system, a square root of negative 1. All right, it doesn't exist in the real number system. However, it exists in the complex number system. And we'll talk about that in the next series of videos. But for right now, when you try to find the square root in the real number system, there is, for a negative number, it doesn't exist. Okay, I hope you enjoy more examples with the square root. I want to do one more. It's different, but it's the same scenario. So far, I hope you enjoy it, and I'll just do one more. And it involves binomial numbers, a binomial number, and just real quick. All right, I'll erase this. Now, I believe that you memorize the three scenarios. When D is greater than 0, there exists two solutions. When D equal to 0, there's only one solution. And when D is less than 0, there's no real solution. All right, let's solve this and see if you all remember what you've been viewing and visualizing. Okay, let's try this one. X minus 1 squared equals to 25 using square roots. And this should take no probably a minute to solve. Why is a minute solve? It's very easy. All right, I'm gonna write it over again. 25. Now automatically, you're gonna see this. Treat this as one whole expression. Normally, you saw the last two examples involving just the x squared, but x minus 1, you can still treat it as one big expression. Excuse me. So x minus 1 squared. So anytime you have a square, take the square root on both sides of the equation. Make sure when you do that, x minus 1 squared, take the square root on both sides, equals to square root of 25. All right. So when you have x minus 1 in this parentheses, treat the whole expression as one single expression. Like the other examples, x with the x squared, when you find the square root of x squared, all of this cancels, and you have x minus 1 left on this side. And then square root 25 is plus and minus 5. And this where you can see that this whole value means that there's two real solutions, a plus and a minus. All right, automatically you know that means that it's going to be a real solution. However, this identifies that there will be two real solutions, but you have an x minus 1. So we have to make sure x is by itself. So we have to split this into two separate equations. X minus 1 equals to a positive 5. And x minus 1 equals to a negative 5. So you're finding the solution for both positive 5 and negative 5. So in solving the solution, we look at the sign and we add the opposite using properties of equality. I'll do it on the same side so that it illustrates that you're using the same properties of equality on both sides. Taking the subtraction, you add its opposite addition on both sides. X equals to a positive 6, and here x equals to a negative 4. So we see here we have two real solutions. Two real solutions. Make this an A and an L. So we have two real solutions. Okay, I hope you enjoyed the session. Just a quick illustration of three types of scenarios involving solving quadratic equations using square roots. This is Dr. Howard, and this is the quadratic series for math, NC Math 2. I hope you enjoyed. You have a great day, and we'll see you in the next series of videos.